man's desire to know the unknown persists. This desire led man from one victory to another. His insatiable search for knowledge for the benefit of mankind becomes acute as he discovers newer horizons. Newer and newer fields open up, a formidable challenge to man's ingenuity. And the unattainable is achieved. Man lands on the moon, a feat unsurpassed by any till now. Resurgent India could not helplessly watch and lag behind in the century's most crucial race for knowledge for the benefit of man. India accepts the challenge and proceeds with the work of putting a satellite into space. Professor Satish Dhawan.
The Indian space program began in 1962 when Dr. Vikram Sarabhai decided to use sounding rockets from the Tumba Equatorial Rocket Launching Range to study the upper ionosphere and atmosphere. As the architect of the Indian space program, his concept of using space for India's development was to utilize this advanced technology for specific purposes which fulfill urgent needs of our country. This became possible because Professor U.R. Rao, who Dr. Sarabhai had selected as being the project director, who already had some experience in dealing with experiments in space, we assigned him the task to organize the team. We hired a few buildings at Pina, which is a little village a few miles away from Bangalore, and Professor Rao and his team rapidly converted these into the satellite laboratory. We have, of course, in this team about 250 young people. Less than a third of them were there associated with the space program a little earlier, but more than 2/3 came from the universities of India, and it's a measure of great satisfaction that this young group, for the first time launching on this such advanced technology, the design, construction, testing and launching of a satellite.
We decided to name the first satellite as Aryabhatta, after our famous astronomer who was born in Kusumapura near Pataliputra around 476 AD. Aryabhatta's contribution to astronomy is immense. He was the first person to say that the earth moves around the sun.
Of course, our Indian space program has in it the design and development of our own satellites and our own rockets. But it's very interesting how the excitement of working on India's first satellite caught on, and everyone in these places, whether it was Bharat Electronics or the CIL or the National Aeronautical Laboratory, who helped us a great deal. The satellite structure was made by Hindustan Aeronautics, and a number of other small and big industries. Hegde and Gole did a lot of work on the printed circuit boards. Soviet Union sent up every year nearly 100 satellites. So when their offer of help came, it was really the offer of a veteran to a beginner. Their help consisted of advising us at various phases of the project. Also, there are certain components like the solar cells, tape recorders and chemical batteries, which in the time frame it would have taken us a great deal of effort and time to build ourselves. But the major thing was also to place the satellite into orbit, for which they gave us a proven rocket. For this, of course, we are very grateful. Among scientists there was a camaraderie, and they freely acknowledged that they also learned something from the project.
Since in this satellite we had additional weight and power available, we have also included 3 scientific instruments for scientific investigations. The main power source for this entire satellite is derived through the beautiful solar cells which are mounted on the body of the satellite. There are 18,000 solar cells, 12,000 active and passive components working inside the satellite. If the connecting wires are put end to end, they will cover a distance of nearly 10 kilometers. They had to build the first environmental chamber for simulating space conditions on the Earth in order to test the various subsystems and qualify them. In order to stabilize the satellite in space, it is spun by releasing gas from 6 gas bottles, one at each time. When the gas is released from this gas bottle, it comes out through the 2 nozzles which are diametrically opposite and provides a spin motion to the satellite. This satellite weighs 360 kilograms and measures 1.6 meters in diameter. The 4 antennas send this data from the satellite to the ground. Similarly, the satellite can be commanded to do various operations on the satellite. The main purpose of building the satellite is to learn about the satellite technology. We have got the ability of building, fabricating, designing and launching a spaceworthy object into space. We have also achieved the entire methodology and culture of space technology.
0 hour ticks forward. A tense excitement prevails. And off goes Aryabhatta, India's first scientific satellite.
Here in Sriharikota, this ground telemetry station is a prime vital telemetry station which receives important satellite technological data whenever it passes over Sriharikota. The technological data like spin rate of the satellite, the temperature inside the satellite is recorded in the station and transmitted immediately to our mission control at Bangalore for the scientists to analyze the data.
With the expertise and confidence gained from launching Aryabhatta, we have already signed another agreement with the Soviet Academy of Sciences USSR for launching second Indian satellite using a Soviet rocket carrier from the Soviet Cosmodrome. The second satellite is far more sophisticated than Aryabhatta. It will carry 2 television cameras and 3 microwave radiometers, the results from which will be very valuable for forestry, meteorology, snow cover and hydrology. Thus, the second satellite will be a forerunner for all our future application programs.